Okay, welcome to Construction Tech Tuesday. Tonight, we are very excited to talk about the technical, the technique, and the technology behind fluid applied air barriers with co-host Kevin Brennan and 475 High Performance Building Supplies, Aaron McCormack. My name is Jay Fox. I'm part of the Passive House Accelerator team, and tonight I'm filling the very big shoes of our director, Zach Semke, who has another engagement, unfortunately. If this is your first time joining us, the Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. It's a mouthful. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. For Construction Tech Tuesday, our co-hosts Shaun, Kevin Brennan, and Mark Wille share the technical, the technique, and the technology of passive house construction tech. Each week, we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction design world to join us each week. And with that, I want to pass it off to Mark.
Jay, that was wonderful. It was great having you on tonight. I can't wait to see who's stealing beers out of your fridge during the show. I'd like to say welcome, everyone. My name is Mark Wille. This is the 10th episode of Construction Tech here on Tuesday nights. And we did, way to go there, Jay. I'll applaud that too. We did take one week off, but we've been pretty straightforward rolling into the 10. It's a joy having new faces come on every week, both in the audience, those engaging in questions, those sharing online, and certainly the presenters. I'm excited for our presenter tonight. I'm excited for our presenter next week, but I'm not going to give away who that is. And the presenter a week after that is Brandon Weiss. He's a personal friend, and he will be showing us an off-site modular project that follows the Passive House standard under FIAS. So, Shaun, over to you.
Good evening, good morning, wherever you are in this planet. Hello, how are you? I'm Shaun, and I do have a little friend that I brought into the screen tonight, Mr. Bernie Sanders. And I bring this up because interesting thing about Mittens. He had a look like no other, and given, in my view, the success of last week's news, it was great for him to kind of take a bit of the highlight because everyone could agree with what he was trying to do. And interesting enough, about 11 years ago in Vancouver, Mittens, now these are actually the 10-year anniversary version of the Mittens, but Mittens can play a very important role of bringing together nations. At the Olympics, Canada came together and everyone was wearing red mittens, which unfortunately are in a box somewhere because it's not really cold in Vancouver, but I did find this pair, which I got last year at the anniversary. So again, these little things in time where we can come together and group and collaborate. This event is doing that as well. The Passive House Accelerator Tech is a way for all of us to just deal with COVID and come together and learn. And it's great to see that we've been doing it for 10 weeks. Again, as Mark said, 1 week off because I needed a break from all the other happy hour stuff we're doing. Next week, we've got Prudence, who's going to talk about air bearer fuck ups. And I can say that because that's not a swear word when you start it off with a PH, because we know what PH is about. It's passive house and all about learning the 5 passive house principles. So great to have my friend, Mr. Gootexpert, the director of shenanigans of 475, Aaron. Kevin, off to you, my friend.
All right. Well, welcome. I personally want to thank Aaron and Matt for going to site and filming a video with us, which I'm excited to show with you guys later on. The main topic of this discussion is fluid applied air barriers. How did we get here? Why are we going? Like, what's the big deal about fluid applied air barriers? So in New York City, our largest surface areas of the projects we work on, of these brownstones, is the party wall. They are the party walls. So compared to the front and the back wall, these are 6,000 square foot surface areas connected to adjoining buildings that a lot of times people don't consider as major air leaks. And the opportunity to seal them has taken many evolutions. So I'm just going to share like a photo montage, I guess you can say, of the projects we've worked on, and I'll take you through the evolution of how we've gone through the actual process, or how we got to the versions of the air barriers that we're using today. So this first picture is the first rendition of the party wall that we had at the first project. Now, how I got into Passive House was kind of by mistake. I was a weatherization instructor and installer, teaching hands-on air sealing and insulation. And then I stumbled across Tomas O'Leary at a New York Passive House event. And he said, "Hey, does anyone have any training center space?" And I said, "I have training center space. I work for a company that just took on 8,000 square feet under the big promise of ARA that everyone was going to get trained and taught weatherization is great and change the world under ARA." But we realized shortly after that we weren't really seeing the numbers that we needed. So I looked at Passive House as a way of leading towards the edge of excellence. So we brought the Passive House tradesperson course to that facility in the Bronx, and wonderful people took the class from the construction teams of the Backstingwe projects. And this first project, the superintendent came on the project. It was an early adapter of the Passive House process. This is like the third or fourth large scale brownstone that was being undertaken. And the strategy chosen on this project was to use AC grade plywood, not AC grade plywood, I'm sorry, FSC certified plywood, because this was a lead project and they needed to have FSC plywood. And on this project, they were using 1/2 inch plywood shot into the wall with kind of like fastened to the wall with these kind of like ram set little nails. And it's 1/2 inch plywood, and the boards kept getting wet. They started moving. The seams were taped by the carpenter who was not trained. So it wound up at the end getting just a little offset, meaning when we did our final blower door test at the end, the results weren't great and we had to chase down a bunch of leaks. So this is the first version of it. So on the second project, we had a wonderful brownstone in Brooklyn Heights. And at this time, we were the air sealing installer. The team at AEA took on the role of being the air sealing installers. And as you can see, we have lovely substrate of this interesting cement block, existing plaster that didn't need to go anywhere and was in decent shape, infills in other areas. This substrate is a disaster. It's not easy to go on. And our strategy was to use a fluid applied air barrier. So we bought a spray machine, spraying the Stowe air barrier onto the wall using the spray machine. That's our setup. The guys are doing great jobs. But we realized as we were doing it, we needed to use a bunch of components, the fiber, the fluid, and at what thickness was it going on. And we still had that same struggle of where are we able to get the material on the wall thick enough, and when can we test it and make sure that it's airtight. So we did a decent job. We detailed a lot of different joists in other areas. We spent a lot of time cleaning and prepping, which is kind of like one of the big things of this. Each one of those joists had to be detailed. And these pictures are a mess. So let me go across here. And this project is the final product that was on this project. So it came out nice and smooth. Then we fast forward to a few other projects, and this picture shows our new process, right? So our new process was to hit the critical details first with the fluid applied air barrier, detail out everything as we go along, and install it on the wall. In this tricky area, we used it to go on the wall. We were doing it manually with my cousin Paul on the ladder there, and you could see all the critical details being done. Then we fast forward. We had a retrofit project here. That's a detail of how we're detailing the joists a little smarter. And on this here, you can see you guys are using the caulk gun to hit every little last seam. But the amount of material we used on this, we blew our material budget up probably by 2. So the estimating. Now we've fast forward to version 3, which we're starting to use maybe some of the similar products to the Viscon. We're doing our sequenced air barrier so that we can get our brackets on. But at the same time, we're like, are we putting it on thick enough and at the right areas, right? So we sequence it at the joist and all the particular details. We're doing it, we're spraying it on, and then we're touching up all the little fine holes in between. And then we're finding even more holes. So we added light and we start finding more holes and more holes and more holes. And we wind up doing extra coats and extra coats and extra coats. So I'll share these pictures, but at the end, we had one monolithic air barrier. So that's the story of how we got here. We went from plywood to Stowe to the Viscons and the blower proofs and the Veriseals, and we've gotten better and better at the application. And tonight we're going to break down the process of installing the fluid applied air barriers by 475. So I'd like to thank you guys for taking the time to just introducing this. And I think first we're going to bring on Amy.
Thanks, guys. So my name is Amy Fiala from Baxtingway Architects, and I worked with Kevin a long time. That project that he was showing in Brooklyn Heights was one of my projects, and I've learned a lot from Kevin along over the years. So today, the video that he's going to show was taken at a Baxtingway project that we just started work with R. Sutton and Co. And we're very excited that we were able to start. I'm going to share my screen just to show a couple teaser images of what this building is, and we're going to be doing other educational events on this building. We're working with NYSERDA. It's a winner of the building, one of the winners of the Building Excellence competition. So we are receiving funding from NYSERDA. So we're going to work together with and do a lot of events. So this beautiful historic firehouse, it is a firehouse, or was a firehouse, was designed by the official architect for the fire department, Lee Brunen's son, in 1882, and became the home to engine company number 16 in the Kips Bay area in Manhattan, and then was later converted into a church in the 1970s, and where it was only partially used and fell into disrepair. And now it will be brought back to life with a full-scale passive certified renovation and a conversion into a four-family residence with a community facility on the ground floor. Facade. This is a picture of the facade as it is now, and it's it's well intact. And even though it's not in a landmark district, we are treating it like it's a landmark, and we are keeping as much of the historic fabric as we can, and we're building an addition, a roof addition, with keeping some of the original detailing of the fire hose shaft from bulkhead that was on the roof, and then there are a lot of really cool historic elements in this building from when it was a firehouse, and we are utilizing as much as we can. So just cool railings and existing subfloor and fire equipment hooks that were in the garage on the main floor. And the tin ceiling, beautiful tin ceiling. So it's a fun project, and we're excited to be working with Kevin on this. And there'll be more to come on this project. So I'll pass it back to you guys.
Thank you, Amy. And it's been a pleasure to work with you on many of the projects. You know, we first started working together on Garden Place, and it's been wonderful, and it's good to get the team back together and work on such an amazing project of revitalizing a passive house.
I wanted to say also, Amy will be presenting this project on a Wednesday happy hour coming up. So this was a great intro. You were muted, Kevin, so I jumped in.
Oh, yep. Thanks. Sorry, I hit the button somehow. So one of the things I just wanted to bring up was that apparatus floor, that firehouse that Amy talks about, there was a lot of training that happened there over the years. People were taught how to do their job. And the future of that building, we're really hoping through Passive House, we're going to teach a lot of people how to make buildings Passive House. So the team at RS Sutton is really excited about sharing the mission of Passive House. The Baxtingway team, as you can tell by Mike starting the Accelerator, is very passionate about collaboration and sharing. So this is the first of many opportunities to share how the projects are going to be executed on that project. And with the support of NYSERDA and the Buildings of Excellence we hope to make that like one of the good training places that we can share a lot of information about how we're doing that project. And me and my team are very excited, and we're very happy to have the support of 475. And I'd like to introduce my friend, Aaron McCormack, who is the technical manager for Tech Tuesdays, to the show.
Thanks, Kev. Cheers. So yeah, first of all, I would, in addition to thanking Kevin, I'd like to thank everyone for attending, and thank the Accelerator for having us on. We're founding sponsors of the Accelerator, so it's great to be part of everything. I'm just going to bring up a quick presentation for the specific product that's been used on this particular project. It's called Proclima Viscon. Once we get over that, we're going to jump to the video that Kevin's going to play. It's me and him on site, and he's putting me through my paces, installing the material. Our boss, Flores, here often says he doesn't let me out the door. He doesn't let me out into the public, but I finally got out, and it was an experience to really see what it's like on site, and to really get your hands dirty and go through all the different steps, all the different things you have to think about when you're actually installing liquid applied membranes, because they're not so straightforward. There's a lot of prep work that needs to go into them, and it can be quite a challenge. The particular product, it's called Viscon. It's an air barrier first and foremost. It's also a water barrier, and it has different vapor control properties as well. So in low levels of relative humidity, it's vapor retarding, and as things get much higher, up to the 80, 90, 100% relative humidities, it tends to open up and let vapor pass through. So it's not going to ever do any damage to material. So it's vapor open when it boils down to it. Anytime that it needs to be allowed drying to take place, that's what it does. So regardless of the assembly, it's going to open up and let moisture through. It's acrylic based, so it's quite natural. It's quite eco-friendly. There's no red list materials in the material or anything like that. And of course, it's part of the Proclima family, which a lot of people know as one of the main air barrier systems. It's fully compatible with everything else in the Proclima system. It's predominantly installed with an airless sprayer. I'm sure a lot of the other barriers, liquid air barriers, are installed quite similarly. It can also be applied with paint, with a paintbrush, or it can be roller applied. Whatever is your preference, it can be applied basically. It comes in a couple of different colors. It comes in blue and then dries black. A lot of people like to see a black material once it's dried, and for them it's quite tangible to say this is sealed, this is airtight, this is watertight. And then the other option is white. Kevin's personal preference is white. Once he sees it, he can pick out the different pinholes. He can really see where he knows to find leakages and that kind of thing. And they come in 10-liter buckets, so 2.5 gallon buckets. And on average, it's about 150 square foot per bucket. There is a sister product to the Viscon. It's called the Viscon Fiber. Viscon, when you apply it over a surface, the maximum gap it can cover is about 1/8 of an inch. Whereas when you have to come to maybe where you meet a joist, a floor joist, or you meet a corner, you meet a slight gap, it tends to be much larger than 1/4 of an inch. So Viscon Fiber comes with a polyethylene fiber built into it, and it can bridge a gap up to 3/4 of an inch. That comes in 5-liter buckets, and it can be brush applied, it can be trowel applied, and of course it comes in blue, dries black, or it can also be in white. The materials that it can be applied to, this is a funny enough topic, given that it's in Europe, liquid applied membranes are still quite new. Walls, if they're historic masonry, it's plaster that goes onto it, or stucco, something like that. Whereas what we found is a lot of people will purchase Viscon with the intention to do gaps and different transition points. So where wood meets masonry, or maybe you have metal pieces. These particular pictures, if you look on the bottom left-hand side here, it's a CLT project with metal connectors, and the installer was able to just completely coat everything, and the material can bond to both metal and the concrete. You can also go on to wood fiber insulation, onto sheathing materials like OSB or plywood. And some people will often just have a bucket of the material on site, and if they think there's a leak, they'll just throw it on with a brush. You can see here in the bottom right hand corner, it was a pipe penetration going through some timber. So they were just sealing it up. Some people would often just buy an extra bucket or just one bucket, even if they don't have the Viscon on site, they'll have it just to cover up any little gaps or penetrations, that sort of thing. One of the main areas where we've seen this is floor joists. It can be one of the trickiest transition points in definitely any historic build, but even in new builds, it can be tricky as well. Historic masonry, the project you're going to see, as I think is it 4 stories, Amy can chime in, but every floor detail has to be addressed. Every time you get to a new floor joist, that needs to be sealed. And that can be a lot of work when you go with tape. You have to, you're cutting, you're trying to fit membrane up in between. You might have to put some blocking materials, some timber in between to fully seal it. Whereas it's quite simple. It's quite straightforward. You just get a bucket out and you can completely cover it, or you can use the airless sprayer and completely get through everything. It's also a very, very flexible material. So where you have masonry that meets timber and they dry at different rates, it's the sort of material that can move and adapt with time and with movement and settling. When I got on here first, I noticed there was a couple of European people on the line. I think there was maybe some guys from the UK, maybe someone from Germany. And coming from Ireland, it is definitely, when we think of historic masonry projects, you would not put anything on them other than lime. That is like our go-to mindset, to kind of pay homage to the existing material, but also to do it in a careful way. This particular project, I just happened to be on Twitter before I came on and I saw this. I said I should include it. It looks like it was some sort of sand cement with gypsum material that went onto a brick. I think this person is in the UK. It was some sort of Georgian brick. And sand cement, if you get the wrong mixture compared to the existing lime mortar and the brick that's already involved, you get these different drying rates. And the gypsum will actually trap moisture. So as the moisture rises through your brick and then tries to dry towards the inside, it just gets stuck. Then you get all this damage. So it's kind of it's definitely an area of concern when it comes to historic masonry. It's something that requires a lot of attention and detailing. Thankfully, with the Viscon, it becomes a vapor open material. So there's never any chance of it trapping moisture or causing sweating or causing damage that might take place like this. Yeah, it's a huge area for concern. And I know, coming from Ireland, we have a huge amount of Georgian buildings, and maybe some people here have heard of the Celtic Tiger, but it was a time when money was good and there was no recession and there was no issues, and you were finding the cheapest material to go into very expensive projects, very delicate materials, and people were just putting on the wrong materials, and now we've ended up with a lot of damage to very beautiful projects, and it's a real shame. So it's really, you really need to be careful and specific about what sort of materials you put into these sort of buildings. And I'm sure Amy is well aware with the final wall assembly that has to go in here as well. You can't over insulate either. It's a very delicate subject and we should be quite cautious. So any of the time that we recommend our Viscon for this sort of application, we will also do a WUFI calculation to make sure that it's safe and that we're not over insulating and the material is right for the exact project. But as I said, here in New York, the culture is to use liquid applied membranes. It's harder to find lime plaster over here. The specific type of lime plaster is kind of harder sought, and maybe the trades aren't so easily available. So what has become the norm is the liquid applied membrane, and Viscon is definitely one of the more common ones that we see, particularly here in Brooklyn because of the historic masonry districts that are around here. Typical drying time for the material is about 24 hours, depending on humidity levels. So you can put on about 2 coats as long as it doesn't go over 39 wet perms. So you can get relatively thick levels of material, and you can probably have a full air barrier in 1 coat, but it's best practice is to do it in a couple of parges, I guess. Then just down on the bottom right hand side, you will see the typical historic masonry retrofit assembly that we tend to see, where the Viscon will go on the inside of the brick. There is a smart vapor retarder inboard of the overall wall assembly, and that stud bay is filled with cellulose. So something that can absorb moisture from the wall, allow it to dry. So whatever way the moisture is moving, you're stopping moisture to get in there. And then if it ever gets in there, we can let it dry out. Then the Viscon, it's a certified Passive House Institute component. So it's been fully tested. It's part of the family. It's part of the Passive House family of airtightness, and it was tested with our Solido SL tape, Contiga Solido SL, which is designed specifically for masonry projects. Then the specs on the specific material. We tested it to ASTM 2178, which is the standard test method for air permeance of building materials. It was basically 11 wet mils of material that went onto a gypsum board, and then it is pressurized, or the air is trying to suck through the material to about 300 pascals of pressure, and we couldn't get any air to actually move through it. So once it becomes a homogeneous material, nothing really can get through it. It's also passed the water resistance test of ASTM E331. And that's a little bit more, it's not your typical WRB test. It is the test that you would use for water penetration of windows and doors and curtain walls. So it's another step up than a normal WRB. Long-term temperature resistance, anywhere from -40 Fahrenheit to 176 Fahrenheit. If you live anywhere where you get fluctuations of heat like that, you're in real trouble, and I'm sure you're not really worried about your air barrier at that point. You've serious other problems. But anywhere from very cold climates in Canada or all the way to hotter climates in Texas or Florida, anywhere like that, it doesn't ever have any issues. It won't bubble or anything like that. If moisture ever tries to pass through it, it just opens up and lets that vapor pass on through. The vapor variability, like I said earlier on, it's similar enough to our Intello product, which is a smart vapor retarder. And the perm rating goes from 0.3 perms all the way up to 25 perms. So according to building code, you need to be over 10 perms to be vapor open. This is 2.5 times that. So anytime moisture starts to accumulate and the relative humidity gets higher and higher, this material will open up and let the moisture move on through. We also did water column tests of 6.5 feet, and the adhesion test, it is tested to 166 pounds per square inch. So once the material gets on to a substrate, whether it's masonry or plywood or something like that, it's not coming off. It's good luck trying to get it off. It's going to be rather difficult. We also have a lot of blog posts on our website that just go through the different testing that we've done. And if you just look up Viscon, you'll see it's all linked on our product page. There's also a 3-part spec available on the website. So any architects that are looking to just copy and paste, there you go. It's readily available. And then just to finish off, we're very happy to announce the launch of a new product this year. It's coming March 21. It's called the Aerofix, which is an application gun for the Viscon product. The Viscon is going to now come in sausage form, so 20-ounce sausages. The Aerofix is, you can attach it to an air compressor and you can apply the Viscon to all these tricky little details. Maybe if you're in a retrofit case or you need something quick or you're in an awkward situation, it saves the labor of an airless sprayer, which requires quite a lot of setup. This is very straightforward. You just attach it to the air compressor, adjust the pressure on your gun, and then you can get through all the different nooks and cranny details, whether it's floor joists, whatever the case might be. You can lower the settings down enough that you can actually run a caulk bead, and then you can also spread a vaster spray. So yeah, that's coming in 2021, and it's also going to be in the video that you guys see. But yeah, I think that's all from me for the minute. Kevin, Excellent. Are you ready to?
I'm ready.
To maybe jump in with the video?
Thank you, Aaron. We're going to jump in on the video. Just to precursor everyone, the beginning part of the video is a little difficult to hear because of background noise and the fact that Aaron has an extreme brogue. I apologize for both. I have no control over both, but I'll share my screen and get the video up.
Our goal would be to clean out the surface entirely. There's no point applying liquefied memory dust and grease, dirty residues, making sure that everything can be fully applied to the brick so that there's no room for error and fall. When the wall is dusty and brittle and falling apart, the material from the wall gets mixed in with the fluid applied air barrier, and it creates almost like a new kind of mixture. The roller gets all dirty, it doesn't stay on. So it's good to get it nice and clean and debris-free. Then the second step is filling the holes, right? So we can fill the holes with a complete hard coat, which is a lot of work, and effort. We shoot for super tight passive house levels. Sometimes we'll do that. We'll most likely be doing that on this project. So we can do a couple of things instead of just charging. We can fill the holes with viscose fiber, liquid applied membrane, which can fill gaps up to 4 times an inch. Or alternatively, we can cover it up with a piece of tape and completely cover larger gaps with some tape. And then the final option, you're a fan of this is spray foam. Just can't foam into some of the larger gaps.
Yeah, that's your last ditch effort. So my general order of priority is if there's masons repointing the wall, doing any kind of masonry work, let them fill the gaps with the line-based mortar, the mortar that matches on the brick. And then if I come and I'm all set up and the spray is set up and I'm ready to spray and I find a few holes, I just hit it quick with foam. And the foam dries rather quickly, 20, 30 minutes, and then we can coat right over it. As opposed to waiting for the masonry to dry 18, 12 hours, maybe 24 hours. All right, so prep work, the tools of the game. We got to get all the loose debris off the wall. So we use a mason's hammer, make sure it's all sound, that any loose debris is going to come off. The next one is the manual brush, typical tub brush. And this gets off a decent amount, but it's a lot of manual labor. Anything that's really heavy duty or hard, you could use a wire brush. The wire brush gets all the fine bristles and nooks and crannies inside of the brick off. Through pain and trials and tribulation, I've realized there's got to be a better way. And for us, the better way is it's a polisher, and a polisher with a brush attachment on it, and then we can cover the wall pretty good. But the only downfall of that is all the dust you create should be captured in the negative air machine as close as you can, so you don't create a lot of dust on site. And then the final one is just little touch-ups with just an impact gun and the brush attachments on it. That's the flat one, and this one's pretty good, getting all inside. All the little nooks, the nooks and crannies inside the wall. So once we get it dust-free, then we'll give it a blow down with the blower. And you'll be amazed at how much air goes into all the little holes and cracks and crevices and gets it out. So that's technically our process. As I'm brushing it down, you can see that large chunks of the water are coming off. It creates a cleaner environment. You can see it was getting a decent amount of dust out of the lip. They're going to repoint all that, hit it out. And then in order to make our air barrier install a lot easier, we asked them to do a slurry mix or porridge coat of a lime-based mortar. This is a spec mix, and it's just Portland and lime, and they mixed it with water and made it kind of loose. And we showed 3 different methods. This method was just wet, where they wet the wall. The large holes, the holes that are bigger, I'd say you could actually stick your finger in. I like to use the foam. We just fill it a little, get it so it comes flush. And then as it expands, you just knock it.
And 3/4 of an inch, we can use the viscose fiber. This has a fiber in it that allows us to bridge those larger gaps that the normal viscose can't.
And he's not really like painting it, he's pushing it in the hole. One of the important parts is lighting, to be able to see the holes and where they come in and change your perspective. From it straight on, it may not look like a hole. Clap it into the hole and press it in. Sometimes you need a little more. Just put the material where it needs to go and then just scrape it out. bonded, and then it's going to get another coat for the material.
Okay, for larger gaps that neither the spray foam or the viscon fiber can cover, it's best to just go with some tape, completely cover the gap, and then we can spray over it. So this tape is called Petiga Solido SL. It's designed specifically to go onto masonry. Doesn't need to be primed. So it's pretty important to mix the product before we start applying it. Sometimes during traveling, you can get just some sort of like residue on the top of the material. So it's good to just remix it all together and make sure that there's some consistency throughout the product rather than going straight in and getting some thick gums.
See the top. The other thing you want to make sure, especially on a cold day like today in New York City, that it didn't freeze during travel and transport.
A thicker roller will apply more material, and a thinner roller will limit the amount of material.
So we'll show you Aaron with the thick nap roller, the 3/4, and this one is the 1/2-inch nap roller. And we'll show you the difference. He's put. When it's called chevroning, that means that you put it on nice and thick, around like 30 to 40 wet mils when you start to see that. That's a good sign that you put it on at a right thick. When you see the straight orange peel texture to it, it means that it's kind of thin. And to compare Aaron's nap roller to my nap roller, which is a lot thinner, you're not painting. So you want to make sure that you're staying in nice clean lines and you're applying it the right thickness. So I stay up and down for a clear path. This is thicker than this. I like this. I'm going to have to do a second coat here. That's what this means, that it's thicker. That this is a high boy pump. The high boy pump pulls the material from the bucket, that the dipstick goes right into the bucket. And then this is the primer. It's going to pump out the material. So I'll prime that now. The pump is primed. The material's going through the pump. Now we just got to clear out the material that's in the gun. We'll change it from pump to pressure. Cycling out the water that's in the line. Control this guy. Reduce the pressure, the pump pressure. And we'll sample with the spray tip. Right? The spray tip will clear out the back, the reverse of it, and then we'll get it. I like to sample on like another area that normally you don't really use, but for demonstration purposes, we'll just sample right here. So what's telling me there is that as it's coming out, it's called fingering. It doesn't have enough pressure. Another area. A little more pressure. You can still see the fingers. A lot better. So the general process of spraying the air barrier is that you ride the wave from left to right or up and down. So as I'm spraying here, these bad boys up. Right. Come down and work. 1, 2, 3. 1, 2, 3. 22. So we're quite a bit thicker than the minimum, but we've got a nice even coat. We'll let this dry. And you can see that there's all the little black pinholing. With that pinholing, we have like a coating that's on here at 22 wet mils. One thing you can do is you can back roll it, which I think is recommended, and then try and fill in those holes. So I would take the roller and I'm just trying to smooth everything out, right? Just back rolling what's already on the wall, just evening it out and trying to get the material into those little holes while it's still wet. It'll save you a lot of time in getting the material on the wall quick and then filling the holes manually with the roller. The back roller presses it into the nooks and crannies of the wall. And then hopefully all you can do is go back and touch up some wall areas as opposed to going back and touching the entire wall up by hand. So this is the posi test. It's known as the bubble gun or the ASTM 1186. It helps you find leakage with a soapy solution. So I'll just give you a demonstration of how leaky the wall is without the air barrier. And then if we can get a spot where the air barrier is dry, we'll do it. So the soapy solution goes on. So it's showing that there are porous leaks in all these surface areas. Leaks here, leaks here, leaks here, all for this one surface area. And that's just where the soap got in and was able to form the bubbles. This helped me learn on the job site where my mistakes were. And it was like, all right, I need to slow down and do my back roll a little better, or I need to add more thickness to the wall. Because if this amount of leakage is here, when I have the air barrier on the wall, I'm gonna have a hard time with my final blower door. It's seeing that the gaps and the cracks are there, even though the air barrier is on, it's not sealed 100%. So you have to spend a little more time with the two coats, or you back rolling to fill all those little holes. We'll try this one. Alright, so the machine's running. Put the soapy solution on. I don't see any bubbles. No big bubbles. This was able to get to the pressure. This is 900 Pascal. On the other surfaces, it wasn't able to hit that pressure. Only got up to around 700 Pascal. And then within this field, I don't see any actual bubbles. There's one here, right at this spot, but it may have come from the edge of the seal of the dome. So one coat, some leaks. One coat, back roll, no leaks. So it has to look clean, smooth, and 100% filled in. Right.
This is our new product coming in March 2021. It's the Viscon Aerofix. It comes with the Viscon in the sausage form. It comes in white, black, and the fiber in white and black as well. It's easily attached to an air compressor. The sausage goes in, we adjust the settings, and then we can apply the product.
That was an excellent video, in my my opinion. Aaron, thank you very much. Matt, thank you guys for your work. I think it was great. I was unable to see the chat, so I'm in the dark on what was happening. So did
Lots of good questions.
Your thoughts, guys?
Mark, do you want to chime in and while I get the questions posted?
So I first want to comment on my props to Kevin and Aaron. When you take the time and show the deliberate adjusting of the sprayer and the continued review of the prep work needed of the facade, as well as the review of how thick the deposit is on. All these details, if your contractor or your specifier or your supplier are not including this in your project, then they are missing out on the technical, the technique, and the technology. So big props to that one, Kevin and Aaron. And I enjoyed the video. I love the bubble blaster. I love the arrow fix. And I love the balanced accents of the Aaron Brogue and the Brooklyn Brennan.
What accent?
That's Staten Island, Brennan. That's Staten Island, Brennan.
It's Staten Islandese, guys. It's Staten Islandese. It's a different variety. It was a lot of fun to make, and all of the lessons learned there have come from the trying to make this stuff work. You know, the early on presentation was lessons learned from the first project, the third project, the fourth project, and these stories that are told all come from those pains. So
great stuff. Let's get into the questions because we're hitting close to the top of the hour here. So again, thanks, Scott. I agree. The building they're doing this in does seem like it's right out of Ghostbusters, and Kevin's the guy we got to call.
Shaun, do you want to give Aaron the floor for his mentor and then jump into questions? So it's going to roll into the happy hour, the overtime.
Yeah, let's do that. So, Aaron, you talk about your mentor. Jay, fire that up. Jay, I'll talk about sponsors, and then we'll just dive into the overtime.
Okay. I kind of wasn't even thinking. I never thought about this up until yesterday. But there's two guys that I know very well, and if it wasn't for them, I definitely wouldn't have a place in the world of construction or passive house. Barry Williams is a close friend of mine. He gave me a job when I was in college doing drafting and taking levels and going to site and just helping with surveys. And then he said, you need to grow up and, find yourself. And I applied for a job at Ecological Building Systems, and eventually they offered me a job. And Barry said, go take it. They're wizards over there. So I eventually got a job with Ecological Building Systems, and Niall Crossan was the senior engineer at the time. He's technical manager now. And between those two guys, I've learned so much. And I probably wouldn't know anything about building science if it wasn't for these two guys. I remember my first day with Niall, he taught me about passive house. So my first day as a fully fledged adult, I guess, in a career sense, I learned about passive house, and I've been kind of involved with it since. So just shout out to those guys.
We all stand on the shoulders of the people who taught us before. You guys work for 475, and they pioneered the Brooklyn brownstone passive house. They came through frustration and said, hey, there's better products out there, and they made a difference by creating that company. And you work for them, and these guys taught you the way. And I'm very proud to call all of you guys friends, but also we collaborate on a regular basis, and it's been a great culture and environment, and I love every part of it. So I also want to give a shout out to Johnny Rosvani, that he put that video together in quite a long time, and not a lot of time, and he did an amazing job. And challenges of sound on construction sites was pretty amazing, and I think he actually made us look good, Aaron. I don't know how he did that.
Tough job. Fair play to him.
Great stuff. Thanks, Aaron. Thanks, Johnny. Jay, do you want to give a little praise to the rest of the sponsors that help out the Accelerator?
Absolutely. There we go. All right. Well, thank you so much first to Aaron and Kevin, and for that awesome presentation, for everybody who's here tonight for our 10th episode of Construction Tech Tuesday. Also, thank you to Amy for stopping in. So we at the Accelerator are allowed to put on these events and spread the word about Passive House thanks to our sponsors. This includes our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel RDH Building Science, Stow Corp, and Zola Windows. It's also our stakeholder partner is NYSERDA, and our patron sponsors are BR+A, Brennan Insulation and Airtightness, Initech Windows and Doors, and US Engineered Wood T-Stud. All right, so we've got some really great content coming up here. If this wants to switch, there we go. But first of all, we also have our Passive House podcast. The most recent episode just went up yesterday and includes a conversation with co-hosts Zach Semke and Dennis Wedlick of Barless Wedlick Architects. Dennis is a renowned architect whose work has been featured by the Smithsonian National Design Museum and who's long advocated for equitable access to high-performance buildings and energy security, particularly in rural communities. He's also the author of 5 books, which is pretty impressive. His most recent publication was Classic and Modern, Signature Styles, with his co-author, Alan Bartlett. Tomorrow, we've got Deborah Malels for the Global Passive House Happy Hour. She's going to talk about the new Passive House student residence for the University of Toronto Scarborough. We've already had Maureen Sanchez on in the past to speak about the design of that building, but Deborah is going to shift gears a little bit tomorrow, and she's going to talk about how she persuaded those at the university and other clients to build to Passive House standard. Moving on, next week, Construction Tech Tuesday, we'll have Prudence Ferreira of BR+A, on top of being a co-host of the weekly Passive House Happy Hour. She's also one of the sharpest minds in the entire Passive House community. We're honored to hear her speak about, I was going to say flub ups, but that's just me. Probably another word that she meant. Then we have next Wednesday's Global Passive House Happy Hour with Jesper Cruz, who will stop in to discuss his work on a multi-phase retrofit project in Maine. You don't want to miss that. So with that, we are going to enter into the after hours. So cheers to everybody on a 10th episode.